Good morning, ma'am. This is P. Kumar from the Department of ECA, and my roll number is 23401A0416. Today, my topic is wave propagating in lossless. Subject name is EM Wave 1 Transmission Line. Subject code is 23ECE401. Wave propagation in lossless dielectrics. Introduction to wave propagation. Wave propagation refers to the transmission of wave through a medium. In lossless dielectrics, this mechanism is crucial for the understanding electromagnetic wave behavior. This presentation will cover the fundamental concept, equation and application related to wave propagation in lossless dielectrics. This is the waves of the lossless dielectrics. Definition of lossless dielectrics. A lossless dielectrics is a non-conductive material that does not absorb energy during electromagnetic wave propagation. These materials are characterized by the permittivity, which affects how electric field interact with them. Common examples include air, vacuum, and certain plastics that exhibit negligible energy losses. And the formula is theta t1 is equal sin theta t1 is equal sin theta t root of epsilon naught by epsilon 1. SI is equal sin 45 root 1 by 45, that is equal 0.3333. Electromagnetic wave basics. Electromagnetic wave consists of oscillating electric and magnetic fields that propagating through space. The speed of these waves in a vacuum approximately 3 into 10 cap 8 meter per second. But the speed is reduced in dielectric materials. The relationship between frequency, wavelength and wave speed is fundamental to understanding wave propagating. Wave equations in dielectrics. The wave equations dielectrics how electromagnetic waves propagating through a medium. In lossless dielectrics, the wave equation can be derived from Maxwell's equations. The general form of the wave equation such media shows that wave can travel without attenuation. Propagation constant. The propagation constant is a complex number that describes how the wave propagation through a medium. In lossless dielectrics, the imaginary part of the propagation constant is 0, indicating no energy loss. The real part of propagation constant is related to the phase velocity of the wave. Propagation constant of wave is also called its angular wave number, k is equal to 21. Phase velocity and group velocity. Phase velocity is the speed at which the phase of the wave propagating in space. Group velocity represents the speed at which the energy or information carried by the wave travels. In lossless dielectric, phase and group velocities can differ particularly on dispersive media. Boundary conditions and reflections. At the interface between two different medium, boundary conditions dictate how wave behave. Reflection and transmission of waves occur when they encounter a boundary between a dielectric and another medium. The Fresnel equations provide mathematical framework from analyzing the phenomena. Applications of the wave propagation. Understanding wave propagating lossless dielectrics is essential in communications and radar technology. These principles also apply to the design of optical fibers and wave guidance, enabling efficient signal transmissions. Additionally, they are crucial in various scientific fields, including remote sensing and medical image. Challenges and considerations. While lossless dielectrics are idealized, real materials can exhibit some level of lossless. The dielectric constant can vary with frequency, leading to distortion effects. Accurate modeling of wave propagation in practical applications requires consideration of these factors. Theta t1 is equal sin theta t1 is equal sin theta t root of epsilon naught by epsilon 1. Sin I is equal sin 45 root 1 by root 1 by 45 is equal 0.3333. And the conclusion: wave propagation wave propagation wave propagation in lossless dielectrics is a fundamental concept in electromagnets. Understanding the behavior Understanding the behavior of waves in this media has scientific applications of the technology and science. Continued research and developments in a materials science will be further engage our understanding of the wave propagation differences. Okay. Thank you, ma'am. Thank you for giving this opportunity.